Good morning or good evening. Welcome to the next session of the Software Language Engineering Conference, and you have come here to witness the software language engineer's worst nightmare. My name is Vadim. This is not my first time at Splash. I'm a professor of software evolution at the University of Twente in the Netherlands. I've worked in pure research in some places in the Netherlands and Germany. I worked in pure teaching in the Netherlands and spent several years working in the industry at Raincoat and Raincoat Labs, where we were migrating large software systems, legacy software systems, from the mainframe to the cloud and developing new compilers for them, analyzing them, developing new tools, and so forth. I identify as a software language engineer, and some of these things that I've done over the years have made me a sort of a legacy connoisseur. Today I will be your guide in the world of legacy. And just one slide to remind you that legacy matters. And by legacy I mean large, expensive to replace, business critical software systems. There has been some research and some investigations done by Gartner Group and Reuters and this kind of places that are professionals in collecting this kind of information that says that something like half of the applications in the banking sector are built on COBOL. So have at least some COBOL in it. There are quite a lot of applications that are still being built in COBOL from scratch. And whenever you're using your bank card to pay for something, quite possibly there is some COBOL code that's running behind it. Legacy systems are huge, so in general they estimate that there are upwards of 200 or 220 billion lines of code only in COBOL in existence. But the largest that I have seen in one system, that was Bankia, that was one of the big Spanish banks, not even the biggest. And it had 250 millions of lines of code. Raincoat Expert helped to get rid of a fourth generation language that was used in that system and to go to pure COBOL, enabling all kinds of tool support and whatnot. And just a reminder, we keep talking about COBOL because this is sort of the image, the representative, the quintessential part of being a legacy system, but it's not everything that there is to it. There is PL1, which is even harder to implement, an even larger language with a lot of pitfalls. And all of them are third generation languages, so there is also the second generation assemblers and the fourth generation with a lot of sort of badly designed languages that compile one level lower, and they need to be compiled after that with all kinds of leaky abstractions and whatnot. This is a situation that I found myself in more often than I'm comfortable to admit. I'm the person on the left, and somebody is presenting some wonderful new technique in software language engineering and saying that it works for everything, or at least almost everything. I'm the person in the room that asks if that applies to COBOL. The quite reasonable answer is that no, it does not. And it is sort of unfair for me to ask that because COBOL is a huge language. It takes years to implement a decent tool for it, even for people who really know what they're doing. So, there have always been this conflict, the inner conflict in me that sometimes got out and became an outer conflict. I was being inspired by things like Mini Java, right? There is this book on compiler construction, and it just says, okay, Java is a big language. Here's a tiny subset of it, and we're going to implement a compiler for that. Another wonderful example is featherweight Java, right? A language that has formally defined semantics, and if you want to tell the world how your new extension works, then you can just make a tiny extension. It fits on the paper, it fits on the slide. You can quickly showcase what you are extending, and of course, if you want to extend it for a big language, you need to work more, but that's just engineering. The challenging part is tiny. So after last Splash, I've embarked on a journey to make the same for legacy world. And as a result, I've had this thing called BabyCobol that I'm presenting now. So read the paper, go to the website. There is a lot of information there. I will go from the techniques that you need as a software language engineer and how they manifest in BabyCobol. First up, there is lexical analysis, right? A very simple thing that you do when you cut the input stream into tokens, lexemes. The thing is, in many legacy languages, the indentation of the languages and the layout is punch card driven, right? So you have a punch card represents one line of code. You need to identify where that line of code belongs in a program and where that program belongs in a system. So that eats up several characters, which leads to a problem that sometimes your lines don't fit on this punch card, and therefore you need another column, for instance, saying that this is a line that's not done yet. It will be continued on another punch card. And please correct me if I'm wrong, but I don't know any framework that supports this, the specification of this, where it just literally say, okay, you need to cut it like this, and this is how line continuations are implemented. It's possible to implement manually, but it's this kind of pain that you don't want to live through, but you have to if you're implementing a legacy language. Whitespace is insignificant in some languages like Fortran, but the whitespace can still be used for disambiguation. So it cannot be, again, simply discarded and then reconstructed when you are done with lexical analysis. And in some languages like PL1, keywords are not the same as reserved words. Things like if or do or while you can use as names for your variables. And that adds an extra level of complication yet again. And think in particular about IDE support, right? Because that's the crucial place where you usually want super fast techniques. So ideally you would work with a regular language level techniques, because they are the fastest that we have. If you want to take all of these into account and be precise and be sound, then even context free level techniques are not enough. And, that's a problem. So please solve it. Going further, there is syntactic analysis. And COBOL has this huge perform statement in inline and out of line. In particular, I'm being here inspired by the inline, and loops in general in PL1 and in Fortran, and in some fourth generation languages, in particular App Builder. So enough slides. Have a look at the code. This is a program in BabyCobol, and it has a loop and an and the loop has some clauses like varying, saying which variable are they varying from, which value to which value, by which step, and so forth. So far so good. Some of these clauses can be left out, also so far so good, but between the adjacent clauses you can put statements. That is a real life problem that I've encountered when I was implementing the compiler for App Builder, Tiala. And this suddenly adds a whole level of complication, because then your clauses become they get lifted to be statements. And it is not enough in a grammar to say that instead of a statement I have a statement or the clause, because they can occur inside some of the statements. In this case, an if statement. So your statements, your regular statements, are also polluted with the fact that you are now parsing within a loop. Going further into static semantics, the tradition in normal languages and mainstream languages nowadays is that you have statements and you have something like methods, and then you have classes, and they all sort of fit into each other. In COBOL and some other legacy languages, you also have a level of sentences, which is between a paragraph that would be an approximation of a method, and a statement, which is really a statement. So sometimes you can have statements like next sentence, which is basically a go-to that goes to the next, where the next sentence begins within the method. There is also this perform through statement, which says that these methods, or in this case paragraphs, they are written in this order in the program accidentally, and we want to execute them in that order that they are written in the program. And if you want to go to or exit from them, we just ignore you and we continue executing the way we want to execute it from the call place. The way we are used to see imports work in normal mainstream languages is that you have some kind of import or include statement, and that is being replaced basically with the contents of another module and is being put in here. The same in COBOL and BabyCobol, but you can also do a lexical level replace at the point where you are importing it. So you can literally sort of self-modify your program when you are importing some other module. This complicates context flow analysis, as you can very well imagine. If you analyze data flow, that's also not much easier. In particular, when you are assigning statements, COBOL has this thing called move corresponding that's been inherited by many fourth generation languages that compile to COBOL anyway. And that means that you can assign one data structure to another data structure, and they are completely different. They have different layout, they have different sizes and everything, but there is a username and an account number in one, and a username and account number in another one. So whenever you're assigning that, it's not an assignment, it's sort of a name-based flexible overlay of the structures, and then you are only assigning things that name match. You can also have sufficient qualification, so A of B in legacy languages mean what in languages like Java would be B.A. So B is a bigger structure and A is some field in it. But it could also mean that B occurs once somewhere in the entire data structure that we have in our system. There is some B. And then we want finally the leaf node, the field A, and it could be that A is not a member of B, but it's a member of some C that is itself a member of B. And it could be that B is not something that we have in our scope, but it is within the scope of something else that we have in our scope. This is called sufficient qualification, and it's also a feature of BabyCobol. And you also have some figurative constants like high values, like the highest value there. And then it depends on the data type, what is the highest value of that particular field. But you can assign it at the same time to several fields, and then you need to figure out different types and basically desugar it to several assignments. GoTo statements is very well known for being considered harmful. Well, how about an alter statement? It's not being considered at all. Dynamic semantics of GoTo work this way. So you have several paragraphs that are, as I said, almost methods, except that you can also use them as a target for your GoTo. And then you have an alter statement. The first argument of alter is the place where the GoTo is. So that's the name of the paragraph which contains a GoTo. And then you say that you alter it to proceed to something else. So in essence, you change this GoTo from GoTo exit update record to GoTo exit rollback record. Or you can just go to a variable and then you can assign the value to that variable at runtime later, as you can do in computed GoTos in Fortran, in some systematic way, and in a less systematic way in languages like Rex. To summarize, BabyCobol is a language full with problems from the legacy world, and it is a language that's hard to parse because of all the strange things with contractions of expressions and white space and case significance and insignificance and so forth. It's also hard to analyze because there are things that complicate the construction of the data flow and control flow graphs. It is very hard to execute because it basically allows the self-modification of a control flow at runtime. So a lot of the machinery needs to be postponed to the runtime. And it's still easier to handle than real legacy languages. I still maintain that it's possible to implement it within one course, let's say on a master level, on a graduate level, or it's easy to implement on in a paper, or it's possible to take a cherry pick one feature from BabyCobol and to show a slide of to showcase how your framework or your language workbench can do that. Not all harmful and hard to implement features that I know of found their way into BabyCobol. For instance, there is this implicit typing in Fortran, then can itself also be implicit, so you don't even include the statement, but some undefined variables follow some undefined naming convention in order for the type to be assigned to them. So as you quite often see, experienced old school Fortran programmers just starting all their programs with implicit none to get rid of all the implicit typing, and then if they want it, then introduce at least implicit typing explicitly. There's also this example of Rex. I don't have time to go into this, but please ask a question if you want to know this. But basically, it's a language that has assignments and it has a drop statements. It doesn't cancel the assignment per se, but it cancels the place where the assignments have no power, and that leads to very strange situations, very hard to implement. Also, when you're dealing with real languages in the legacy world, you are faced with bad documentation or the lack of documentation. You are dealing with a lot of languages at the same time, and they all work together in some sort of cocktail. You need to integrate your tools and your solutions into existing ecosystem, which is not an easy thing to do. And in many cases, you even need to go so far to keep the bitwise representation in memory the same as it was on, let's say, a mainframe. Maybe some of these things at some point I'll find a way to sneak it into the next version of BabyCobol or something. To conclude this, there is a paper, there is a website. Go there, get more information if you want. Reach out to me if you want some information directly. In general, I think that this is a useful thing that I will definitely use in teaching, in order to prepare the next generation of language engineers that are ready to face problems that are in the legacy world, as simple as that. And it is also useful as a benchmark. If you are advertising your framework for static analysis, for syntactic analysis, or your fancy language workbench, if you can show how you can implement BabyCobol, or at least some feature of BabyCobol, in a concise and expressive enough way, then basically you are showing that your tool is legacy proof, that it can be used to deal with real life, large, hard problems in the legacy world. So thank you for your attention. If you have any questions, I'll answer them now, and follow GrammarWare for more updates. Thank you.